Hello everyone, welcome to our pre-calculus pre-recording video. This is our lesson 3. 3S means this for the summer we are giving a new indication so that these lessons are prepared for the summer semester. So application problems and the domain and range of the trigonometric functions and applying the fundamental trigonometric identities. These are the topic name. Application problems from 6.2, just to be more specific. Okay, so let's look at the agenda first. Finding the approximate value of the trigonometric functions, application problem from this exercise, then sign of the trigonometric functions, determining sign and applying the fundamental identities. These all topics are related to that. Okay, so let's have a look. These maths are for finding the approximate value. See, approximate value of the trigonometric expressions rounded to 2 decimal place. This is important, 2 decimal place. First of all, for this math, you will be using calculator. So let's say cos 14 degree. So you will be writing cos in the calculator, cos 14, see, cos 14 then equal to, so cos 14 degree equal to 0.97. So we will just write here this equals to 0.97. Okay, suppose this one sec 21. So we do not know sec 21 equals to what, or sec 21 calculator cannot do. That's why first of all we will write 1 divided by cos 21 equals to what? So first of all, cos 21 equals to this. Then you will write 1 divided by answer equals to this. So 1.07. So let's write 1.07. 0.71. So 1 you do not have to write because 2 decimal place. Okay, this is pi, sine pi divided by 8. Pi means 180. Instead of pi you can write just 180. So see, first of all 180 divided by 8 equals to 22.5. That means sine 22.5 equals to what? Sine 22.5 equals to 0.38. So you will write this equals to 0.38 like that. Now this math is super crazy little bit. See, tan 1, sine 1. So naturally students make this mistake. This one is sine 1, this one is sine 1 degree. So there is some difference between them. Okay, there is some difference between them. This is 1 degree. Degree calculator can do. So this is in radian. That means here we have to do that conversion thing. So we know that pi radian equals to 180 degree. Pi radian. So therefore 1 radian equals to what? 1 radian equals to 180 divided by pi. 180 divided by pi, and this pi is 3.14. So 180 divided by 3.1416 equals to 57 point something. Now we have to write tan 57 point something. Tan answer I gave, tan 57 point something. This equals to 1.55. So see, this is interesting here. So answer comes 1.5573. So if we round this to 2 decimal place, 2 dp means 2 decimal place means up to here we have to write. But you see, we have to put a dot here. But you see, after the digit 5, this 5, second 5, the number is 7, which is more than 5. 5 or more than 5. If the number is 5 or more than 5, then you have to add 1 with this number. That means this will become 6. This is a rule. If the number after the number, suppose up to 2 dp we are taking, So after 2 dp, after 2 decimal place, our next number is, if the next number is 5 or more than 5, then we have to add 1 with the last number, or with the number that we are taking. So this is the rule for rounding. In our this example actually the next digit was less than 5. That's why we just have to remove them. Okay, so this is a rule for the rounding. Suppose, let me give you more examples. Suppose if it is 1.32324, then you can just write 1.32. If the number is 1.325, then you have to add 1 here, because this number here is more than 5 or more than 5. Okay, so you have to add 1 with this with the number that we are taking. If the number is 1.328, still you have to add 1 here, 1.33. It will become 1.33 if we round up. Okay, so the rule is, if the last number here, suppose we are taking 2 dp, we will look at 3 dp place, and 3 dp place, if that 3 dp place is 5 or more than 5, we have to add 1 with the 2 dp place, 2 decimal place. Okay, so this is the rule. We can discuss it if it confuses you, no problem, during the class also. This is the application problem from our book related to the projectile motion. It may look scary, but don't get scared. Don't get scared, because actually the function and all the values are given. Only thing that you will have to do is you have to put the value here, and value here, and do the calculation in the calculator. So don't get scared by looking at all these numbers. This is a math from our book, and this is 121 to 24 number maths. There are 4 maths from the same question, similar type of question. Projectile means if you throw something in some angle, then you will see that in our practical life, real life, you throw something, it goes there and then it comes back. Just like this object, you throw something, it goes up and then it comes back and hit at a point. Okay, so some projectiles equation is given, r of theta equals to this and h of theta equals to this. This is the range function, this is the maximum height function. So this is the height function. Now if they tell you angle is 25 degree and initial speed is 500 meter per second, then find out, suppose, range, or find out height, then what you do? We just have to put theta equals to this value 25, and initial speed is this equals to 500, and the value of g is given here and g is given here. So you see, this math is related to meter per second, so we have to use this value of the g in this question. That's why we have used this value of this question in the g, and this is the answer. Okay, and then we have to use similarly, same thing goes. If the question is find the range, we will do the math here. If the question is find the height, we will put the value here and do the calculation. See, here we have used 2 into, this is 25, so we have tried to find out the range for this question also. 123, projectile is fired at this angle, horizontal speed is this meter per second. If the projectile is, find the height and the range, both of them is obtained for this 123 number math. So for 124 number math, we will have to just use the 50 degree here for the theta, 50 degree, and 200 feet per second for the v0 or v0, and 32 this value for the g, because it is feet per second. That's it. Okay. So we will just have to switch if it is given meter per second or feet per second. Both value is given here, so we have the choice of taking which one we like to take. So in this math, let me recap. In this math, what you will have to do is, we will have to put the given value in the given function and do the calculation in the calculator. Okay, just like this, put the value and do the calculation, find the answer, like this. This is 124, similar way, 124 number math is also done here. This is another math from our book. This is like designing a fine decorative pieces. Similar kind of situation based on this thing. The whole question is whole function is given, and the question is, if the angle is 30 degree, if the angle is 30 degree here, and the radius of the sphere is 2 centimeter, then what will be the answer? Okay, then what will be the answer? So see, we have a couple of cases here. First one is 30 degree. So if angle is 30 degree, then what will happen? If angle is 45 degree, then what will happen? If angle is 60 degree, then what will happen? Okay, so we just have to put the value. See, we can just put the value 30 degree here, 30 degree here, and the value of r is 2. So 2 cube. Right. 2 cube means 8. That's why we can directly write here 8. We do not have to carry the calculation again and again. Okay. So let me just write it here for the flexibility. So see, 1 divided by 3, we know the value of it. We know the value of it. Then pi, we know the value of it. Pi means 3.1416. From the calculator you can also find. Then r equals to 2, it is given here. R equals to 2 centimeter. So 2 cube. So it will become 2 cube. 2 cube means 8. Then the value of angle is given 30 degree. So first we will use 30 degree and do the math. So for 30 degree, answer will be this one. Then everything will remain same. Just angle will become 45 degree, and for 45 degree, answer will be this. Then everything will again remain the same. Just the angle will be 60 degree. For angle will be 60 degree. Then we will get this answer. So basically, we will not have to do anything for the question. I mean, there is no twist, or there is no swing, or there is no modification based on these statements and statements. We are just examining the calculation skills here, or developing the calculation skill here. All right. So based on that problem, there are some practice maths you can practice for the practice. Okay. Now this is another thing here. Let me take a 10-second break. Yeah, 10-second break is over. I'm cooking rice, and the water is just overflowing there, so I have to just decrease the heat there. So, or else all the water will just evaporate. Yeah, Anyway, let's come back. Sign of the trigonometric functions in the given quadrant, like all positive, this, and this. We can prove it in many ways. Actually, we can prove it in many ways, but just to give you a brief idea about what happens in different quadrants. In the first quadrant, suppose if you try to find out sine 30 degree equals to what, cos 30 degree equals to what, tan 30 degree equals to what, all the value will come positive here. Okay, all the value will come positive here. So this is one way to examining it. Another way to examining it is, already you have a very important concept of unit circle. And in the unit circle, you have the idea that on the unit circle, your x represent the x value represent the cos theta, and y value represent the sin theta. So this represent the cos theta, and the y represent the sin theta. So you see, think about it. What will be the x and y in this box? What will be the x and y in this box? You see, this is the negative side. This is the negative side, and this is the positive y. This is negative x and positive y. So the coordinate of this point will become minus x and plus y. That is why in this box, cos is negative, sin is positive. In this box, cos is negative, sin is positive. If in between sin and cos, any one of them is negative, then tan will also be negative. That's why in this box only sin is positive, only sine is positive, others are negative. Because tan equals to sine divided by cos. So basically, if sine is negative, cos is positive, then the whole thing becomes negative. That's why. Now in this box, you see, think about it. What will be the coordinate of x and y in this box? Eh. So suppose if I write here some point here is something. Then what will be the coordinate of the x and y? What will be the sign of the x and y in this box? This box is negative x and negative y. So basically it is negative x and negative y. So that's why individually sine is cos is negative, sine is also negative, but tan is positive, because you see, if both of them is negative, negative sine divided by negative cos, so negative negative positive. That's why tan is positive here in this box. So this is called third quadrant. In the third quadrant, tan is positive. Now here in this box, see, this is the sign. This is the sign. So see, x comma y. Let's write it here, x comma y. So the x is positive here, but this y will be negative, because you see y is going down here. If you want to understand, you can just write, give some arrow sign here, give some line here. For this point, you have to come to this point. You have to come here first, which is positive. Then you have to go down, which is negative. Down means negative. Down and left means negative. Down negative, left also negative. Okay, so you see here, our cos is positive, sine is negative in this box. So from the unit circle, we can understand it. Okay, from the unit circle, we can understand it. So in the first quadrant, all positive. In the second quadrant, sine positive. In the third quadrant, tan positive. In the fourth quadrant, cos positive. And there is a nice mnemonic. There is different types of mnemonic to memorize it or to keep it in mind. One is called all should take candy. All should take candy. All should take candy. All should take candy. Candy means cos. Take t, should s, and all means everyone is positive here. So this way you can keep it in mind. Another one is all should take chemistry. So that way also, which is not a good idea. Everyone should not take chemistry. Oh boy. So suppose this situation. Where is this situation? In which this is some exercise based on the previous slide, like application of the previous slide is this one. Sin theta is negative, sin theta is less than 0, tan theta is also less than 0. In which quadrant it is possible? Sin theta is negative, tan theta is also negative. Where it is possible? Think about it. Sin theta is negative, tan theta is also negative. So see, first of all, this is not possible, because in this quadrant sin theta is positive. This is also not possible, because this quadrant tan theta is positive. This is also not positive, because in this quadrant everything is positive. So this quadrant is the answer. That means quadrant 4 is the answer. Because in this quadrant, cos, see, all should take candy. So only cos is positive. Only cos is positive in this quadrant. Only cos is positive in this quadrant, and all of them are negative. This is how we know. Okay. Now suppose this one. Sec theta is negative, sin theta is positive. Sec theta negative means actually it is cos theta negative. You can think about that, because cos and sec will have the same sign, because they are just only reciprocal of each other, not the negative reciprocal, just reciprocal. So basically they will have the same sign in each box. Suppose in this box cos is negative, cos is positive, that means sec is also positive here. So they will work in pair. Now in which box sin theta is positive? Sin theta is positive here and here. In these two boxes, sin theta is positive. But they said sec theta is negative. Sec theta is actually positive in this box, so that's why answer is this one. And in this box, only sin theta is positive, everything else is negative. Okay. So this is how we can find out which one is the answer of which part. We'll practice them during the class. Now the domain and range, this is just to build your concept about this, how to find out the domain and range of this. This is the sine theta graph. This is the sine theta graph. If we put the value of theta like theta equals to 0 degree, 1 degree, 2 degree, 3 degree, 4 degree, 5 degree, 10, 20, 100, 200, 500. If we keep putting the value of theta, then we will get this graph for the sine. And you will notice that the maximum value of sine is going to +1 and minimum value is going for the -1. That means sine theta has maximum 1, minimum 1, maximum +1, minimum -1. So the range of the sine theta is +1 to -1. And domain is all real number because all the value you can put 500, 1000, 1 million, billion, you can put everything. So this domain and range chart is actually developed that way, just by looking at the properties from the graph. So we can put any value we want. This is the cosine theta, same here. Maximum value is 1, minimum value is -1. This also goes from this side to this side, and so we have cos theta and sin theta and cos theta, similar kind of property. And tan theta is actually, you can see if we draw the graph of tan theta goes for infinity. So basically the range of the tan theta is going to the infinity, from -infinity to +infinity. And at some point actually tan theta is undefined because tan theta is sin theta divided by cos theta. So at some points tan theta will be undefined. Tan theta is undefined at some points. So for recapping, actually we can look at the graph. I mean, what is the graph of that function? Then we can think about what happens in the graph. That way we can actually take the decision. So the domain and range thing we can find out that way by looking at their graphs. That's the most convenient way to look at their graphs and to understand the domain and range of the function, because that is what is visible to us. At some points, as I said, tan theta is undefined. For example, tan theta equals to sin theta divided by cos theta. Sin theta divided by cos theta is tan theta. So sin theta divided by cos theta is tan theta. From that we can actually I have some guest arrived, so that's why I have to open the door. Anyway, so sin theta divided by cos theta. Now you see, you will notice that at some point they will say that this and this is not possible for see x all real number except order integer multiple of pi by 2, 90 degree. 90 degree. At 90 degree, this is undefined. The reason is this theta equals to, if we put 90 degree here instead of theta, just showing you for building your concept, you can see. If theta equals to 90 degree, we put here, 90 degree we put here. Why it is undefined? You see, if we put 90 degree here, then sin 90 degree equals to 1, cos 90 degree equals to 0. That's why this value is undefined. 1 divided by 0. Anything divided by 0 is undefined. That's why. Okay. So we have the undefined value. So this is how this domain and range thing goes. Let's go to the other part. This is the fundamental trigonometric identities. Very important thing. Some of them already you have the idea. Suppose tan theta equals to, many times we are saying tan theta is the ratio of the sine and cos, or tan theta comes from, you remember, y divided by x, from our unit circle, y divided by x. y is our sine and x is our cos, so this way. And cosec is 1 by sine, sec is 1 by cos, and cot is 1 by tan because they are reciprocal of each other. Sin square theta plus cos square theta equals to 1. This is actually another very interesting thing. This comes from the Pythagorean theorem. Let me show you that. Let me show you that. Let me show you that. Suppose this is a unit circle. Let's say we have it here and we have it here, and we have it here. So by now you all know one thing, and that is what is x and what is y represent here. What is x and what is y represent. So you know that x means our cos theta, which is this side. So basically this side is our cos theta. This side is our sin theta. This is our 90 degree, and this is the theta. Suppose in my figure this is the theta, and this is what? This hypotenuse length is what? Hypotenuse length is 1 because it is unit circle. See, it is written everywhere. Hypotenuse length is 1. So what is the Pythagorean theorem? Pythagorean theorem tells us cos square theta plus sin square theta equals to 1. So we can write here. Pythagorean theorem tells us that x square plus y square equal to 1, or base square plus perpendicular square equal to 1, or adjacent square plus opposite square equal to 1. Okay, so sin square. So see, we get this sin square theta, sin square theta plus cos square theta equals to cos square theta equals to 1. So we get sin square theta plus cos square theta equals to 1 this way. And other formula also actually we get from this line. If you want to derive it, other formula also you will get from this line. How? Suppose you divide the whole sentence by sin square theta, then you will get another one formula. Let me show you that also. You will not need many of these are just to develop your concept. In the exam you will not have to prove or establish any of this, or this is just to show you how it comes. Suppose you divide the whole sentence by cos square theta, so this divided by cos square theta, everything divided by cos square theta, okay. Then this divided by cos square theta, so you see sin square theta divided by cos square theta means tan square theta, plus cos square divided by cos square equals to 1 divided by cos square theta. This is cos square theta here. So 1 divided by cos square theta means 1 divided by cos means here 1 divided by cos means sec. So we have sec square theta here. Sec square theta here. Which is our this formula, second formula here. So this formula actually we can derive without memorizing also. Okay. Now we divided everything by cos square theta, so we get this formula. To get this formula, we just have to divide everything by sin square theta. Then we will get this formula. These are the fundamental trigonometric identities. We will use them for solving and developing couple of things. So let's see where we go. This is an example important for many occasions, many things. Sin theta equals to this given, cos theta equals to this given. So you have to find out the other 4 trigonometric functions. This is the last thing for our today's lesson recording. So sin theta equals to minus 3 by 5, cos theta equals to 4 by 5. So how can we find out the other thing? Tan theta equals to what? From here, tan theta equals to what? Let's use some black color. Black color will be better here. So tan theta equals to, we know that tan theta equals to sin theta divided by cos theta. So sin theta means minus 3 by 5. Tan theta, cos theta means 4 by 5. Then we have minus 3 by 5. If we want to write it in multiplication form, then 5 will go up, 4 will come down, and 5 cancel out. This 5 and 5 cancel out, so we have minus 3 divided by 4. This is our tan theta equals to. So now if you have tan theta equals to what? Now we can find out this is sin theta equals to this, cos theta equals to this. So cosec theta equals to what? Just the reciprocal of this, which is easy. Cosec theta equals to minus 5 by, cosec theta will be minus 5 by 3. And then sec theta will be what? From here we can find out the sec theta. So sec theta will be just the reciprocal. Reciprocal means just you have to flip the numbers. 5 will go up, 4 will come down. That's it. So sec theta will be 5 divided by 4. Then this is tan theta equals to minus 3 by 4. So cot theta will become minus 4 by 3. And this is the rule for all the maths here. Okay, for all the maths we will have to follow the same rules. Just only one inclusion for other maths. For some other maths is if you see any square root number in the denominator, you have to rationalize it. We have to rationalize it. That's it. Suppose instead of 3, if you see that this is 4 divided by root 3, now we have to remove this root from the downside, and to remove it you have to multiply both up and down by the same number. You have to multiply, so it will become minus 4 root 3 divided by 3. So now your downside is rationalized. So for some math you may see the root number in the downside, then in that case you have to rationalize it, or else all the maths here is just like this. Okay. So this is the exclusion. Our answer is here. So they said that find the exact value of the remaining trigonometric functions. So this is the exact value of the remaining trigonometric functions. This is our let's say this is our number 1, this is our number 2, this is our number 3, this is our number 4. So 2 of them are given and we have to find out 4 because total is 6. 2 of them are given, we have to find out 4, so that total is 6. Okay. So I think that's all for this recording, and these are the works that you can do, and we can practice this maths also. Of course we will practice these maths during the class, and the other maths also that we have shown there. These recordings may seem little bit longer. The reason is actually for our summer semester all the class is also longer. Do you understand? So basically all the class is something like double class. And one class means actually there is 2 class there inside the class in that 1 class time frame. Okay, so that is the reason sometimes our content is little bit lengthier. There is no other way to short. If I make it more shorter, then this content actually will miss something, But there are something that we can make shorter in the future. We will do it. This is at the beginning. That's why we have to explain everything. Alright, so thank you all. Thank you very much and have a wonderful day. See you all in the class. Bye.